We are live. So good morning, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. And we are really excited this October because all month long, we have been celebrating and showcasing space. By month's end, we will have had 65 sessions from around the world, and over 45 of those are with amazing engineers, scientists, astronauts, and more that are pushing the boundaries of space exploration and research. So we're really excited you guys could join us for that today. Right now, we've got 5 classes joining us from across Ontario, all Ontario classes today. So I want to give them a chance to do a bit of a shout out. We've got Miss Damasio's grade 6s in Richmond Hill, Ontario. Hi, guys. Hey, we've got Miss Saunders, grade 5, 6s in North Bay, Ontario. Hi, guys. Awesome. We've got Miss LaRock's grade 6s in Manotick, Ontario. Hi, guys. Awesome. I love the enthusiasm, everyone, today. That's great. We've got Miss Woods, grade 6s in Bradford, Ontario. Hi, guys. Hey. And last but not least, we've got Miss Charles's grade 6s in Brampton, Ontario. Hey. Of course, the reason you guys are all here today is for our speaker. So we are joined live at the Canadian Space Agency by electrical engineer Jamie Sevigny. She trains astronauts and other amazing people how to use robots on board the International Space Station. She used to do that, and now she gets to be a project manager for various amazing missions like the RADARSAT Constellation Mission. So I don't want to steal her thunder. I'm going to turn it over to her to share all the cool stuff she does. So without further ado, thank you so much for joining us today, Jamie, and take it away.
It is my pleasure to be here. Thank you so much. I think it's wonderful what Exploring by the Seat of Your Pants is doing. A space month in October, that's wonderful. And I'm very proud to be part of this amazing list of people who you have speaking to youth across Canada. So it's a pleasure to be here today. This is the second time actually that I'm presenting with Exploring by the Seat of Your Pants, and today the focus is going to be living and working in space. So it's a bit about the astronaut job. Now, I am not an astronaut, but I did work many years in training astronauts on how to use robotics. So you get to know a bit about the astronaut job, especially when you're chatting with them over lunch and so on. And also in the day-to-day job and the requirements for what's required to become an astronaut. I was also involved in the last astronaut recruitment campaign where Canada selected its latest 2 astronauts. So I know a bit about astronauts, and I'm here to share about that wonderful job. And you'll also get to hear about a lot of really cool things that Canada does in space. So it's really great to be here and share this with you today. So I have been at the Space Agency for quite a long time. I've been here for about 17 years, and it was about half of that where I was doing astronaut training, and then moving on to project management, where I got to design and deal with the project management on a RADARSAT Constellation Mission. That's an Earth observation satellite, and I got to be part of the team who set up the ground segment, all the antennas and the ground systems and the softwares that are used after the satellites are launched, they were launched this summer. So I got to be part of that really cool team, and I'm very happy to be here with you today. So today, now I actually lead a program where the Canadian Space Agency is looking to use its really cool missions and projects and activities to show youth in grades from kindergarten to grade 12 the really cool things that you can do if you have education in science, technology, engineering, and math, but more specifically, a space career. So where we really want to show Canadians the cool possibilities for youth if they continue with science, technology, engineering, and math, because there's lots of new possibilities that are coming up for Canada in space. And we're going to talk about a bit of those as well. So if we move to the next slide. Thank you. I have my colleague here helping me out managing everything. I'm trying to get down to the next slide and I can't, but I'm going to try to figure it out.
That's okay. We can do things amazing. Got it. We figured out slides together. I love it. There you go. Perfect.
Yeah. We can train astronauts, but sometimes it's the software that's difficult, right? So I put up a picture, a really cool pictures, and just take a second to look at it, observe it, and just absorb and think about the the beauty and the work that went into this project. This is the International Space Station. Many countries came together to put this huge engineering endeavor together. This International Space Station has been orbiting the Earth since 1998, so long before some of you were born, and almost half of my life ago. So you guys were born into a reality of space, things constantly being in space, and astronauts constantly living and working in space, which is pretty amazing. So Canada gets to be part of this. There's the Russians, Americans, there's Europeans, there's Canadians. Many countries have contributed to this incredible engineering feat to put this up in space. And when we think of space, we tend to think of things really far away. But I'll challenge you on a very clear night, if you figure out that the International Space Station is going to be flying over you, go outside on a clear night and you will be able to see the International Space Station going by. It's a really bright, it looks like a star, and it's pretty impressive to think that we humans put that up in space, and it's now a really interesting place where we can do a lot of science experiments, and we have always 3 to 6 astronauts who are living and working on board the space station for many different reasons. So Canada, so if you look at it, I'm just going to point out a couple of features about the International Space Station. You see a long, skinny, it kind of looks like a scaffolding. It's called the truss segment, and I like to call it kind of train tracks, and I'll explain to you why in the next slides. And this is a structure for the International Space Station. You'll see that there's solar panels on it. It's also holding the radiators. And then I want to point out the cans in the middle. They look like little cans. Those are the living quarters where the astronauts live and they do their science experiments and so on. And then sticking out the bottom of one of the cans right in the front is our Canadarm2. So part of Canada's robotics that we contributed to the International Space Station. And to give you an appreciation about how big that is, I'd like you to picture 5 hockey or ringette rinks side by side, and that's about how big that International Space Station is, which is why you can see it at night. I'll go to the next slide. All right, so here you have a gorgeous picture of Canada's robotics that we provided to the International Space Station, starting with, well, the Canadarm was the first component that was sent up. And that was sent up in 2001. We'll go into a bit more of the details in terms of the use of the Canadarm2 and why it's beneficial to the space station. And then in 2002, we sent up what's called the mobile base. So do you remember I said there was that truss segment going across, and I like to call it train tracks? Well, the mobile base is kind of a train that goes along those train tracks, and the Canadarm2 can sit on it and can move along the space station. And that was really critical for when we were building the space station and even doing maintenance on the space station so that the Canadarm could go far from one end of the space station to the other. So that's the mobile base. And then you'll also notice that the Canadarm2 is holding on to something that looks like it has little arms as well. That's Dexter. So that's another very sophisticated robot. And that one was used more for, that is still being used for maintenance on the outside of the space station. And so Dexter was sent up in 2008. So, oh, I have a fun fact for you. I have a $5 bill here. And if you look closely, you'll see that Canada's robotics are on the Canadian $5 bill. So you'll see the mobile base, you'll see Canadarm2, and you will see Dexter on the $5 bill. So by providing these robots to the International Space Station, that gave Canada the ability to have access to be able to perform science experiments on the space station. It also gave us access to test new technologies in space on the space station, but also it allowed us to send astronauts to the International Space Station. So here we have a beautiful picture of the Canadarm2, and on the end of Canadarm2, you see an astronaut doing some work. He's performing a spacewalk. So a little bit about Canadarm2. It's quite long. It's 17 meters long. So to give you a reference, My husband is 1.8 meters and I'm about 1.6 meters. So we're not even 2 meters tall. And this Canadarm2 is 17 meters long. And it's very, very strong. In fact, it can handle loads that are about equivalent to 8 school buses. So it's very, very strong. So the primary purpose of the Canadarm2 was to put together the International Space Station. We needed something with the ability to be able to move large masses and put them together with a lot of precision. The Canadarm2 was also used to move, and it still is, move equipment around the space station, move supplies, but also, as you see in this picture, to move astronauts around the outside of the space station. The Canadarm2 is also used for something that's very, very difficult task to do, and it requires a lot of precision, is what we call cosmic catches. So you may have heard that every now and then we send resupply missions to the International Space Station, and you have a big cargo that comes close to the space station, and then the Canadarm2 comes and it grabs it, and then it will dock it up to the International Space Station so that the astronauts on board can have water, fresh food, and supplies that they need, could be science experiments and so on. So robots in space are useful for many reasons, especially because going out doing a spacewalk, it's very dangerous. It's a harsh environment being in space. But also, as we mentioned, the Canadarm2 was used to move massive objects. And you may learn in your science or physics classes later that if you have something that's very, very massive, well, it requires a lot of force to be able to get it moving when it's stopped. But if something very massive is moving, it also requires a lot of force to be able to stop it. So robots are very, very key to helping us humans when we're working in outer space. And at the CSA, we're also working on the next generation. So we're looking towards Canadarm3. Which is an even more autonomous and a smart set of robots or robotics for the Lunar Gateway, so an orbiting post with NASA around the moon. So as mentioned, by providing robotics, we're able to send astronauts to the International Space Station. So you've got a picture on your screen of Canada's 4 active astronauts. And so, you know, we have had 14 astronauts in total, but these are the 4 who are active right now. If we look at them, so I'll go over their names left to right. On the far left, you have Jeremy Hansen. Beside Jeremy, you have Jenny Seide-Gibbons. And on the other side of the nose of the plane, you have Josh Kutrick. And then on the far right, you have David Saint-Jacques. And some of you may be aware that David returned from a long mission to the International Space Station this summer, where he spent 204 days on board the space station. So what does it take to become an astronaut? During recruitment campaigns, the Canadian Space Agency is looking for exceptional people with exceptional health. And they need a university education in math, science, engineering, medicine, science, tech type degrees. And they do also need extensive experience and knowledge as well. So we're going to look into the job of an astronaut and what astronauts do in space. So here's a fun picture. You see Julie Payette on the right and Canadian astronaut, retired astronaut Bob Thirsk upside down on the left. But to them, maybe Julie Payette is upside down and Bob Thirsk is not. We don't know. Anyhow, a typical day on board the International Space Station includes scientific experiments, maintenance of the facilities, so even they have to repair the toilet when it breaks. Physical activity is very important, and they also get to take time to observe the Earth. And they have free time where some of them like to do activities like playing musical instruments. They take time to talk to their families and so on. So there's many activities to learn and prepare for future missions, but there's also many benefits of space travel for us here on Earth. So why do we send astronauts is to not only learn for future missions, longer missions into space, but also benefits here on Earth. And if a fun project would be to take a look at all the really interesting benefits that we have here on Earth because of space travel and exploration. So the first thing we mentioned was scientific experiments. And in fact, that is one of the main tasks of astronauts, to conduct science experiments. You probably did these in class, where you know that it takes a lot of time to observe. It could be visual observations, sound, taste, and so on. Astronauts need to make sure to document all of this and to send the data down to the scientists. And in the picture, you see David Saint-Jacques, who is doing a science experiment. One of the human health science experiments that he did many of them while he was on the station. This one is the bioanalyzer, where it can take samples of saliva, urine, and blood, and then it can do some analyses, biomedical analyses on the health of astronauts. So there's many science experiments that astronauts do, yeah, that's a really cool one with David Saint-Jacques. Astronauts also have to perform maintenance. So I mentioned the toilet, but there's other things that they have to do on the inside of the space station, but they also need to do repairs sometimes on the outside of the space station. So here's a picture of an astronaut performing a spacewalk on the outside. So sometimes the robots can't do the maintenance that's required, so we do need to send astronauts on the outside. Some of these are quite dangerous tasks for them. And they do require many hours of training. And when they're out there, the spacewalks usually last for quite a few hours, many hours, and they require the astronauts to have good focus, concentration, but it also requires muscle strength, muscle endurance, coordination, and also dexterity. And one astronaut compared their spacewalk with running a marathon. So you can imagine how tiring it is. So if we go to the next slide. So speaking of that, astronauts need to not only be in shape when they go on a space mission, but they also need to maintain their physical fitness. So think of a typical day and how many times you walk around or you move around to get from place to place. And without even knowing it, you're using your muscles, you're using your leg muscles. And so without even actually doing exercise, you are exercising every day just from walking from class to class, walking to your bus, getting up to go get something out of the fridge, you're using your muscles. So astronauts being in microgravity, they need to work extra hard to work their muscles, because by floating around a space station, they're not using their muscles too much. So astronauts have about 2 hours a day of physical activity, physical training that they need to do. And this is necessary because their bones and muscles no longer have to support their weight. And also their cardiovascular system, their heart, can start to get lazy if it's not required to move them around the space station. So they have a lot to do in a day, including 2 hours of physical fitness. This is another job of astronauts. So astronauts are pretty impressive people, and one of their tasks is to go out and talk to people. And here you see a couple of pictures. The one on the left is David Saint-Jacques when he was in space, and there was a downlink connection with some people on Earth. And also you see on the right, Jeremy Hansen, who's giving a talk to a school about his job as an astronaut, which is very inspiring. So as an astronaut, communications is very important, not only in public relations type of scenarios like the pictures that you see, but also, could you imagine being in a space station, in a small space station for 6 months with the same 3 people? So it's also very important for astronauts to be able to have good communication skills with other people, but it's also very important for them to have very good teamwork skills. So these are things that we look for when we're selecting astronauts. Aha, so we've talked about a few things that we look for when we're selecting astronauts. And what the CSA has done is we've put together a really fun initiative for educators and teachers and youth in grades 6 to 9. So you all seem to fall within that age category, where the Canadian Space Agency and many, many partners have worked and put together some really fun activities linked to what it takes to become an astronaut. So the activities are divided into three categories. One is the science and tech, because as we mentioned earlier, astronauts require a science and tech background. They do a lot of science experiments. They need to understand how the computers work. That's one category. The next category is fitness and nutrition. As we mentioned, they need to be fit and take care of their bodies in space. And then the last category is communications and teamwork, because as we mentioned, this is very critical for astronauts to be able to work in teams and to communicate with others, whether it's in a small group or to a large group. So we've put some really interesting activities together. They're on our website. Educators can go online and download them and run them with you guys. But then, and an incentive for educators to run these activities is that if they would like to do them, if they're going to run some in their classrooms, they have a chance to apply for an astronaut or a space expert to come and visit their groups, their classrooms, their schools, and so on. So the Canadian Space Agency will be sending its astronauts across Canada in spring of 2020. So just this spring coming up. And then for youth, for you guys in grades 6 to 9, if you participate in some of these activities, the Canadian Space Agency is going to select some youth from across Canada to come to the Canadian Space Agency headquarters in St. Hubert next summer, where for a week long you get to train like an astronaut with an astronaut. So if it's sciences and technology interests you, health and nutrition, communications and teamwork, if space interests you, I encourage you all to get online and talk to your parents, get them online as well, and take a look at our Junior Astronauts campaign on the Canadian Space Agency website. So here we go, some fun pictures where you see science and tech, David Saint-Jacques when he was on board the International Space Station, taking some samples, fitness and nutrition. It's not often that astronauts get fresh fruit on the space station. So it's very important for them to eat well and stay healthy, and teamwork and communications, because you're a small group of people who need to work together in small closed quarters. So I think we can open it up for some questions now.
Outstanding. Well, thank you so much for that, Jamie. That was marvelous. And yeah, we're going to dive in with questions. We've got a few groups watching on YouTube Live as well. So if you guys want to type in questions in the chat bar, I'll pass them on. And I will share all the junior astronaut stuff with all our classes who do fit within the age range. So it's a perfect group today for all that neat info. But yeah, let's dive in. I'm going to start with a question from Miss Damasio's class. If you guys have a question to kick us off, come on up.
Hi. Yes, hi.
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 Hello.
Can you hear us? No, we're on.
Yeah, you're great.
Okay, thank you. Can we ask a question in French or is it in English?
You can feel free to ask a question in French.
Okay.
On a demandé, tu nous as dit que le Canada Arm 2 peut supporter la masse de, je pense que tu as dit 3 autobus, mais there is no gravity in space, isn't there?
I think the question is about the weight of the Canadarm and the weightlessness of what it would be in space.
Yeah, perfect.
Okay, so would you like the answer to be in French or in English?
You can do it in both. You can do whatever you'd like.
OK, c'est une très bonne question concernant la masse versus le poids. Alors, le poids, c'est dépendant sur la gravité, mais même s'il n'y a pas de gravité, un objet a quand même de la masse. So just to repeat that in English, the question was related to the weight of school buses, but weight and mass are two different things where weight is dependent on gravity. And in microgravity, an object still has mass. So there's some equations, Newton's laws, that talk about the link between forces and mass. And so if you have a massive object, even though there is no gravity, if a massive object is at rest, you still need a force to get it moving, to get it to start moving. And once that massive object is moving, you still need, the more massive it is, the more force you need to actually stop the object from moving. So even if you're in a microgravity environment, if you have an object that has a lot of mass, you will need a larger force to be able to stop it. So picture yourself throwing a ball. Okay. Yes, we have gravity here on Earth, but when you can catch a ball, and to catch a ball, you're actually putting a force against the ball to stop it. But that's because the ball itself has a very small mass. Now imagine somebody throwing a bus to you. In order to catch the bus, you would actually have to have enough force to stop the bus from moving because it's got a lot more mass than a ball. So that was a very good question. Even though in microgravity, you don't have gravity, you still have mass.
Very cool. All right. I want to note too, we have Miss Huxley's class, grade 5, joining us from Brampton, Ontario too. So I'm going to come to them last in the queue of questions, but it's very exciting to have them with us today. Let's go now to Miss Saunders' group. If you guys have a question, go for it.
If you were to mix vinegar and baking soda, like make a volcano in space, what would happen?
Oh, you know what? I highly recommend that you go onto the internet because I believe that they have done some experiments. I'm not sure if they used vinegar and baking soda, but they did use an Alka-Seltzer tablet. And there's a really neat experiment where they took a bubble of water, because water behaves very differently in space. It usually stays in a circular a sphere. And when they added the Alka-Seltzer tablet to it, which created a whole pile of bubbles, the air bubbles remained contained within the water bubble. So go and take a look. You can find some really, really neat videos that were placed where astronauts have done an experiment, a similar experiment on the International Space Station.
Very cool. And I'll try and track that down for classes too and share it with them when we're done. But yeah, for now, let's go to Miss LaRoque's class. Come on up, guys. Yep, you're good.
Okay. It's kind of a two-part question, but what have been some obstacles that you have had to surpass throughout your career? And have you ever failed?
Two-part question. Wow, that's a difficult question to answer. Obstacles. You know what? I would say that throughout life, there's many challenges and there's many choices to make in life. But I would say that the biggest thing is that if you do encounter a challenge, is not to let it push you down and hold you down, is that you get right back up and you push past it, or you choose another option and go in a different direction. An example, if you take a look at the astronaut recruitment campaigns, we had some people apply in 2008 who did not get selected to become our astronauts. Back then it was David Saint-Jacques and Jeremy Hansen who were selected as Canada's 2 astronauts. But when we ran another astronaut recruitment campaign in 2016, we saw some of the applicants who didn't make it the first time, they applied again. And so they just kept pushing at it and they went really far and they made it in the top 17 astronaut candidates. So yes, I've encountered my own challenges, but it's within yourself to try to figure out how you're going to deal with it and how you're going to move on. And have I ever failed? I have failed many times, but what's really, really important is that failures shouldn't be looked at, to me, as failures. Instead, they should be looked at as opportunities, because anytime you make a mistake, anytime you fail, there's a learning opportunity in it. And it's to really take a look at that example and to say, what can I learn from it and how can I do better the next time? So without giving specific concrete examples, I think it's a lesson throughout life that it's okay to fail. And in fact, you'll learn a heck of a lot more from your mistakes. And it's to take the opportunity to learn from it and to move on.
Very cool. Well, thank you so much for that. All right, Ms. Wood's class, if you guys have a question, come on up.
Is the International Space Station always moving, and how do we protect it from comets?
Ooh, that's a good question. So yes, the International Space Station is always moving. Do you guys have an idea of how fast it's moving?
Here, I'll go back to them. Let's see. What do you guys think? How fast is it moving? Or to guess?
Go ahead, Una. 360 kilometers per hour.
360 kilometers. Any other guesses? What do you guys think?
700.
700, okay. Tell us, Jamie, what do you think?
It's faster than that. It's actually, I think it's about 7 kilometers per second. So if we go into kilometers per hour, I have a number here. 27,000 kilometers an hour. And so, yes, the International Space Station is constantly moving. It's orbiting around the Earth. And it, in fact, to give you also an appreciation of how fast it's going, it goes around the Earth 15.5 times a day. So yes, it's moving fast. And the other question is, how do we avoid getting hit by objects? There are object trackers. So there's ways that we, not just Canada, but internationally, we monitor all the objects that are bigger than a certain size. I think it's bigger than 10 centimeters. We monitor them to make sure that if any of them, and remember, we're engineers and scientists, we can predict based on their velocity and direction, we can predict if they're going to be getting close to the International Space Station. So if ever we see that there's an object that's going to be getting close to the space station, well, when the space station is moving around, we can change its altitude a bit so that we can make sure to avoid getting hit. But space is big. So even though there's a lot of objects up in low Earth orbit where the International Space Station is, there's still a lot of space for the objects to be moving around. But it is important to track these objects, and we do that, and we have lots of specialists to do that and make sure that the astronauts stay safe.
Outstanding. Well, the student in Ms. Huxley's class is actually waiting really patiently for some time now, so I'm going to turn to you, man. Go for it. And if you have a question. Yeah.
What type of fitness machines do they use in the space station?
That's a really good question. So I'll answer you, and then if you want to know a bit more about them, we do have, I think, a description of them on the Canadian Space Agency website. So they have a piece of equipment that is kind of like a treadmill so that they can run on it, but they need to use elastics that hold them down so they won't float away when they're running. And that provides a lot of resistance for their legs. They also have a piece of equipment that kind of looks like an exercise bike. And then they have other resistance machines that they can use to practice and to exercise the rest of their muscles.
Awesome. And yeah, so I've already got that website up, so I'll share it with classes at the end as well. That's fantastic.
Wonderful.
Yeah, let's go to Miss Wood's class. If you guys have a question, come on up. No, we've done Miss Wood. Sorry, Miss Charles' class. And then, yeah, perfect. I think we've done all out of order here. Miss Charles's class. Come on up, guys.
Just speak up. How long does it take to become an astronaut?
Oh, that's a good question. How long does it take to become an astronaut? Well, there is no specific answer to this because everybody's path to become an astronaut is very, very different. And we've been asked many, many times, what do I need to do to become an astronaut? So the main things are that you need to study in a science and tech degree. You need to take care of yourself, your health and your fitness. You need to be able to swim. You need to have experience. So once you've got, let's say, a degree in some sort of science and tech field, you need to have experience as well, job experience. And then you also need to be able to communicate and work well in teams, and you need to be able to demonstrate that you can do that. So some astronauts are pilots, and so they've gone through a series of schooling and experience to become pilots. Some of them are doctors, like David Saint-Jacques as well, but he's also done a physics degree and many other things. Some have gone through engineering degrees. There's really no exact answer to how long it will take to become an astronaut. And if you're curious about the different types of people who the Canadian Space Agency were interested in, again, on our website, from the last astronaut recruitment campaign, we saved the profiles of the last 17, I think actually maybe even 72 astronauts, but we've got some profiles on our website of the astronaut candidates, the ones who made it almost to the end. And you can see what kind of degrees they studied in, what are their interests and their extracurricular activities. But we only could select 2. So we selected Jenny and Josh. And then once they were selected, then Jenny and Josh had to go through 2 years of astronaut training where they joined an American recently selected astronaut class as well down in Houston, Texas at NASA there.
Very cool. All right, let's go back to our second round of questions, guys. We got about 10 minutes left, so a lot of time. We're whipping through these. Ms. Damasio's class, if you guys want to kick us off with the second one, go for it.
Okay, no. Go ahead.
How long does it take to make the space station?
Ooh, that's a good question. I don't even know the answer to that one. However, the first module, so remember that it takes a long time to actually plan, design, and build each of the modules and each of the pieces of the space station. That took years and years and years. The Canadarm2 was launched in 2001, but the planning, the design, and the building, that had started more than 10 years before. And similarly, all the other countries that were involved in building the International Space Station, they had to go through a planning and design and build and so on of their components. However, the first module was sent up in 1998. And modules kept getting, because you couldn't send up the whole International Space Station into space all at once. We had to do it piece by piece by piece. And that's where the Canadarm2 would come in and help install them and put everything together, kind of like a big puzzle. And that process of sending pieces into space and putting them together, that took over 10 years.
Wow, very cool. We love, as we've been doing all Space Month when it comes to robotic missions, NASA missions, Mars missions, and the ISS, it's really fantastic how many people are involved in the process from every, from the earliest stages to the end, and an opportunity for so many scientists and engineers to get involved. It's really amazing.
Yeah, so grade 6 students are in a great place right now, because if the world is planning to go to the moon and to Mars and beyond, so there will be many, many opportunities for today's youth to get involved in those projects.
Marvelous. All right, Ms. Saunders' class, come on back up for a second question, guys.
What did you use to send the pieces up into space?
Good question. So we used to use what was called the Space Shuttle, and that looked very much like an airplane that was tied to a bunch of big boosters, and it would shoot it up into space. And then the Space Shuttle itself looked like a big airplane, and it was big. And then in the belly of the airplane, or the Space Shuttle, is where we would put a lot of the big components. So the Space Shuttle was really the key, one of the key vehicles that we use to send most of the International Space Station pieces up into space.
Awesome. I'm really glad we got the shuttle brought up. And if you ever get a chance to go to Florida, you can actually see one of the original space shuttles there, which is really fantastic at Cape Canaveral. I really encourage you guys to do that if you get a chance.
Me too.
Oh, yeah, it's fantastic. All right, Ms. LaRock's class. Come on up, guys.
So my question is, who inspires you and why?
Who inspires me? You know what? I don't think there's one person in particular who inspires me, but I get inspired by a lot of different people. I would say that it's usually those people who they try something challenging, and even when they're uncertain whether they'll succeed or not, they go ahead and they still try it. I would say that those types of people, and in French we say ils sont fonceurs. They really try and they go ahead with things, and they're determined. Those people, they really inspire me, and I would like to, as much as possible, be like that, and not be scared to try something new, and you're never gonna do something if you don't try, right? So in fact, I have some kids, and they've taught me that if you don't try, you won't succeed, especially in some of their sports. So maybe the answer to the question then is my kids.
Yeah, awesome, very cool. All right, Ms. Wood's class, come on up, guys.
How do you connect the stars to create a constellation?
With your imagination.
So you don't really connect the stars. Other than, as you said, with your imagination and drawing, there are some really neat star finders that you can use. So if you can locate the different stars in the sky that make up a constellation, then you do imagine that there is a shape that's drawn out by connecting the dots. And there are some apps that exist that do help you find the stars and find the different constellations.
Some really fantastic apps, so like Night Sky, Sky View. There's a bunch that are really, really cool, where even during the daytime, you can see what stars would be there. So I really encourage you guys to check those out too. And again, I'll pass along a link when we're done. All right, Miss Charles's class, if you guys want to come up, go for it. And then we got 2 more questions to take, guys. You guys are doing great.
How long does it take to get to Mars? It's not
How long does it take to get to Mars? A long time. I don't know the exact number. I think I've heard some people talking about a 2-year round trip, but I'm not a Mars expert. All I know is that if we do send astronauts to Mars, it's going to be for a long trip. And so before we can do that, we need to make sure that we know as much as we can about sending humans into microgravity, into space, to make sure that they're safe when we do send them on these long duration missions. Because right now, when we're sending them to the International Space Station, our long duration missions range from 6 months to a year. But if you're going to Mars, it's going to be for longer than that. And so that we still we've learned a lot, but we still have a lot more to learn.
Very cool. And 2 years is about what people have been saying in some of our Mars sessions. So that's fantastic. Several months just to get there, which is amazing.
Yeah.
All right, Miss Huxley's class, if you guys want to wrap us up, come on up.
Hey there.
How many people can fit in a space station?
Oh, that's a good question. So we have usually between 3 and 6 astronauts living on the International Space Station at all times. So yeah, 6 is usually what we have on the International Space Station, the current one that we have. Yeah. For future space stations, maybe we'll have more people. Or
not. Space station, more room. How much fun is that? Jamie, before we wrap up, you've already highlighted a bunch of really great stuff, some amazing apps, junior astronauts, Canadian Space Agency site. Is there any last message you want to share with kids about how they can get involved and engage with space personally?
You guys are in a generation where you're really, really lucky. Information is out there, but sometimes it can be overwhelming, all of the information that you can find on the internet. Canadian Space Agency, we're really trying to provide access to a lot of these things. If you're interested in space, I encourage you to go online and to take a look in a safe environment. But the answers are out there. There's so many really interesting videos about living in space, living on the International Space Station. You guys ask so many great questions, and a lot of the answers can be found on the internet too, in terms of astronomy, stars, constellations, going to Mars, going to the moon, what it takes to become an astronaut. So if you're curious, you guys are very lucky. The answers, you can find a lot of them on the internet these days.
Very cool. Well, Jamie, thank you so much for joining us. And what we do at the end of every session, as you'll know from having joined us before, is I'm going to demute the microphones of every class. And so boys and girls, if you guys could get ready to join me in saying a huge thank you to Jamie and the CSA in general for joining us today. You are all now demuted. Go for it. Thank you guys so much. Awesome, guys. Awesome. We really appreciate you guys all joining us for our Space Month. We're having such a great time. And Jamie, thanks again so much for joining us today.
Thank you so much. It was a pleasure to be here. And I hope that every one of these kids signs up for the Junior Astronaut.
We do too. And we'll pass all that along. And it's such a fantastic program. So get on it, guys, as soon as we're done. Thank you.